Playing in the snow is so much fun. Until it's not. A few days after I played in the snow, I got sick. So I drove to the doctor's office and got prescribed antibiotics and expected to feel better. But it got me thinking, what if the antibiotics never worked? Antibiotics are one of the most powerful tools in modern medicine, and they work by targeting structures in bacteria that human cells don't have, like the bacterial cell wall. But some bacteria still manage to survive, not because the medicine is weak, but because the bacteria are protected at a molecular level. This is where antibiotics like penicillin come into play. They work by stopping the bacteria from building their cell walls by blocking the proteins that normally connect and strengthen that wall. Without those proteins, the cell wall weakens and the bacteria dies, or at least that's the plan. However, some bacteria survive because they produce the right tools, for example, beta-lactamase. Beta-lactamase is an enzyme which are proteins that help speed up chemical reactions. Every enzyme has an active site, which is like a little pocket that only fits specific molecules. Think of an enzyme like Pac-Man, and the antibiotic like the dot it eats. In this case, the antibiotic fits into that pocket and the enzyme breaks it apart. Beta-lactamase does this by breaking a key chemical bond in the antibiotic, changing its shape. And to make matters worse, some mutations can change the sequence of amino acids that make up beta-lactamase. This can alter beta-lactamase's active site. Sometimes when that happens, beta-lactamase is able to break down newer and stronger antibiotics. Bacteria carrying these improved versions are able to survive treatment, reproduce, and spread. And when these bacteria spread, the consequences can be seen in real patients. Beta-lactamase producing bacteria are responsible for infections that are much harder to treat. These include pneumonia, urinary tract infections, bloodstream infections, and wound infections. In hospitals, bacteria like E. coli, Klebsiella, and Staphylococcus can carry beta-lactamase genes. And when antibiotics fail, routine infections can become life-threatening. So the solution? Modern treatments focus on beta-lactamase itself. Scientists design inhibitor molecules that block the enzyme's active site. When beta-lactamase is blocked, the antibiotic is protected and can work again. I got better because my antibiotic worked, but for many infections, that's not the case. By understanding proteins like beta-lactamase, we can design better treatments and stay ahead. So, in the fight against antibiotic resistance, the answer lies in proteins.